So the first example today is from your one of your last homework assignments, and it involves this bullet that's getting launched into a block, and the bullet remains in the block, and then the block falls off of the table and it ends up on the ground. So let's think about what happens in this thing. The bullet initially flies with some speed, and it collides with the at-rest block. So the bullet hits the block. And it sticks. So this is a special thing. It's called a perfectly inelastic collision. And we'll have to use conservation of momentum for this. Then after the collision, the objects move together in projectile motion. So anytime you have something moving through the air where gravity is the only significant force, then projectile motion is the thing that you're going to use to analyze it. And one of the special things about this projectile motion is it's a horizontal launch. That makes things so much easier for us. And the initial height is h, which we know. And the landing is a distance d from the launch. So we tend to know more about the end of this situation, so we're going to have to calculate backwards. So first, the horizontal launch. Now we have to remember that in projectile motion, see if I can pull up some of the equations here to paste in to discuss. Zoom in a little here. This is all in the kinematics section of our course. And I'm going to use these equations. Let me grab a slightly different part of the kinematics. So we're definitely going to have to use this thing, and we're also going to have to use this thing. So the thing with the height is because we have v initial y is equal to 0. It would normally be a much more complicated equation with a v initial y delta t term in there. So let's take a look at that. H is 1/2 gt squared. So if we put in our height, which is 1.0, equals 1/2 times 9.8 times t squared, we can multiply both sides by 2 and divide both sides by 9.8, and that would be t squared. So therefore, t is the square root of 2 times 1.0 over 9.8. So the first step was to think about what happens to the objects in a time sequence. And then we looked at it, figured out what we know, and how we're going to start writing equations. And 2 over 9.8, close parentheses, 0.452 seconds. So that is during this whole process, delta t equals 0.452 seconds. The next thing we have to think about is, now that we know the distance, we can think about how delta x is Vx delta t fits in. This delta x is our distance, d is 1.9 meters, is Vx, times the time of flight, which is 0.452 seconds. So that tells us that Vx is 1.9 divided by answer equals 4.21 meters per second. So that's kind of up here. That's this velocity right there, 4.21 meters per second. But it's also related to this velocity here, v final, as an x component of 4.21 meters per second. Now I don't know the diagonal, the speed of landing, but I don't really care. I'm just pointing out that the x component of the velocity during the flight, from the initial point when the flight starts to the final point when the flight ends, is constant. So now we have to deal with the collision. That's this point here. I'm going to switch colors. And in every collision, you're going to want to find the total momentum. So that's m1 v1 plus m2 v2. And before the collision, we're going to have p total is equal to the bullet, which is 8 grams. 8 grams times v bullet. And the block is not moving. The final, its p total is equal to 8 plus 280 grams times 4.21 meters per second. So as it turns out, even though the universe goes from collision up here to flight over here, our calculation has to go the other way. So we're going to use the final, and we're going to calculate that same speed times 288 and get 1210. 1210, and this is in gram meters per second. And I want to point out that I didn't use kilograms here. I don't have to use kilograms here because I'm relating a mass times velocity in grams to a mass times velocity where the mass is in grams. So there's no sense of converting to kilograms to give myself awkward numbers, just have to convert back to grams again to do this division or converting all mass to grams. So now we can do 1210 gram meters per second is equal to 8 grams times V bullet, and get V bullet is 1210 over 8, which is presumably 151 meters per second. So just to review, this is a multi-step process, and the big thing is there's a collision, and then the next big thing is the projectile motion. And the fact that it's a horizontal launch makes our projectile motion a lot easier. So we just have to churn through it, use in projectile motion, use one of the directions, either X or Y, to find the time of flight, and then plug it into the other one. So we had to use the height, the Y direction information to find the time of flight, plug it into the X equation to find the X velocity during the flight. And then that is what allowed us to figure out what happened in the collision.